Hello, in this knowledge clip I will explain how to check a sample for representativeness. So to have an example of a sample, I have here a survey with respect to an indoor swimming pool called Splash Fun with a lot of questions. And one of those questions is your gender. What is your gender? Are you male or are you female? And we're going to check the sample for representativeness with respect to that particular variable, the gender. Now to do that, I also have an Excel file, and in that Excel file I have all the data, all the answers to the questions of this survey. And here you can see in column F there is the gender, where 2 stands for women and the 1 stands for men. So let's take a look at how to analyze the representativeness for this sample. Now if you want to check representativeness, you have to make sure that the sample distribution of a certain variable, so in other words in this case the gender, so the sample distribution is similar to the population distribution. So the first thing that we're going to do is take a look at how the sample distribution looks like. And we're going to do that with a pivot table, and in this pivot table we just want an overview of the percentage males and females in our sample. So this is it. Let's take a look at the gender in the rows. Let's do absolute and relative frequency together. So I change my sum using the value field settings. I change that to the count, which is my absolute frequency, and then I also add the gender to my values to again change the value field settings, choosing count and showing the value as a percentage of the column total. So that is my relative frequency, where 1 stands for the males and 2 are the females. So if we compare this, so let's put it a little bit more like this. Okay, so what do we have right now? Right now we take a look at our sample, and we see that in our sample we have a distribution of males versus females of 43% versus 56%. So in my sample there were 65 males, 85 females, so obviously we have a little bit more females than males. Now, should we have 50-50 to be representative? Not always, of course. We just have to make sure that our sample distribution represents the population distribution. So the question is actually, well, does that look the same? If you compare your sample distribution and your population distribution, can you say that those two distributions are similar? When they are similar, we talk about a representative sample. If they are not similar, well, it's not a representative sample anymore. So let's take a look at how the sample looks like, how the population looks like. So we see here that in our sample we have only 43.3% males, and we should have gotten 45% males if it would have been perfectly representative. Same for the females. We're over questioning the females a little bit compared to our population distribution. Is this a problem? Well, we have to test that. We have to test this with the test for representativeness, and that test is a chi-square test for distributions, because the chi-square test can also be used to check cross-analysis, to see if you have a correlation with respect to 2 variables. Now this chi-square test has nothing to do with that, and we're just going to compare a sample distribution to a population distribution. Now the null hypothesis for this test, you know every test assumes a certain starting hypothesis, and that is that there is always equality. So there is no difference between, and in this case we are comparing a sample distribution with respect to a population distribution. So there is no difference between sample distribution and population distribution. So that is our null hypothesis to check for representativeness. But there is some difference, and we observe that in our sample we are under questioning the males a little bit compared to the 45% in the population, and we're over questioning the females a little bit compared to the 55% in the population females. Now, is this a problem? Is this a significant difference or not? That's why we are going to check this with the chi-square test. Now, just pay attention here. If our null hypothesis would be true, that would actually mean that we do have a representative sample. Representative sample. Because if the sample distribution looks like that, if there is no difference with the population distribution, well, that indeed means that we have a representative sample. So actually in this case we are hoping not to reject this null hypothesis. But there was some difference, so let's calculate the measure of difference to see how many difference there is, and that is the chi-square value. Using the chi-square value, you can summarize the difference in this case between the sample distribution and the population distribution, and then we're going to see if that is a lot or not. Is that measure significant or not? That's the question. Or in other words, is that difference that we observe between the sample distribution and the population distribution, is that significant or not? Now, therefore, we apply our chi-square test for distributions, and if we go back to our formula sheet here, our decision scheme, you can see that there is also an online calculator available to test for representativeness. So let's go there, and you see that the test first asks for the categories, and we have a category male and we have a category female. So let's enter those categories already, and then it's going to ask for the observed frequency and the expected frequency. Now, the observed frequency are just the frequencies that you observe in your table. So you can clearly see that we observe 65 males. So let's enter that here. We observe 65 males and we observe 85 females. Now, the expected frequencies, we have to calculate them, because the expected frequencies are actually the absolute frequencies that you would expect to find in your sample if your sample was perfectly representative for the population. Or in other words, the FE, the expected frequency here, is the absolute frequency under the assumption of the null hypothesis. So in other words, we have to recalculate our sample findings such that we have 45% males and 55% females, and that is what is meant with the FE, the expected frequencies. So therefore we just apply the 45% on our sample size of 450. Let's fix the 150 with dollar signs such that we can drag down our formula, and then we see that we have an expected frequency of 67.5 males and 82.5 females. So that is the expected absolute frequency under the assumption of the null hypothesis, or under the assumption that our sample would have been perfectly representative. Those are the values that you would expect to find in that sample. So those are the values that the calculator is expecting. So we enter them there, 67.5 and 82.5. Okay. Significance level is again 5%, because we are working with a 95% confidence level, and then here is our output. Let's snip this output so that we can put it in our Excel sheet. Here you get the results of that chi-square test. You have a chi-square value of 0.168 and a corresponding p-value of 0.68 and so on. So let's put that here in our Excel sheets. Then you know where all these values are coming from, and you can see a chi-square value of 0.168. So again, this value summarizes all the differences that you observe between the sample and the population. Is that a lot or not? Therefore, we take a look at our p-value, and the p-value here is 0.68158, which is, and preferably we put this always in a percentage, because we are going to compare this p-value to 5%, to our significance level of 5, and you can see here that we have a p-value of 68.16%. So in other words, our p-value is in this case bigger, which is what was it, 68.16%. This is bigger than 5%, and if our p-value is bigger than 5%, our difference is not significant. So we have no significant difference in this case between the sample distribution and the population distribution. So we're going to not reject the null hypothesis, and that was actually positive in this case, because that means that we do have a representative sample. because there is not enough statistical evidence of difference between the sample distribution and the population distribution. So the differences that we observed here between our sample and our population are insignificant. They're actually just a coincidence. If we would do our sample over and over and over again, it will actually be vibrating around the population distribution. It was just a coincidence right now that we found a little bit less males than we should have had, and that we find a little bit more females than we should have gotten in our population. So we do have a representative sample right now that the differences are insignificant. And that is how you check a sample for representativeness, in this case for the gender.